very interesting set. Have a run through this. So the description is given in 3 different slides. As ever, I'm going to take some time off for you to read and take this in, and then we'll do this later on. It's a fabulous set. It looks like it's a very logical reasoning set, but it's more than plain vanilla logical reasoning. There's a little bit of sets that come in, there's a bit of numbers that come in. The wonderful set and the wonderfully tough set. So read this. We'll discuss this in detail. Don't worry if you're seeing a plain screen with that window without volume. I'm just giving some time for you to read this set. I've moved on to slide 2 so that you get the data in this set as well. I'm going to move on and give you a sneak peek at the third slide as well. It's a fabulous set. It takes a while to just digest the data points and get a sense of how what is going to be. The entire data set here is given in detail on our Facebook event page, which is mentioned in the description of this YouTube video. So watching slide by slide, reading slide by slide is a bit of a pain, as it can be. You just click on that link, go onto the Facebook page, sign in, have a read through all the data in one go. And so it's tough to do a DILR session on just YouTube with a shared screen, because I might be doing it in one sequence, but you might be looking at data slightly differently. I might want to look at slide 1 again. You might want to read this and then want to recap something here. And all of that happens. This format becomes tricky. Which is why I'm a gigantic fan of not just doing live sessions, but actually learning on a learning platform, where you can see everything, try it out on your own, then move on to the solution. Otherwise, we have too much wasted time here and there, right? But we'll make do with what we have. The YouTube is a fabulous platform that gives us this much. So let's not whine about the last 2 bits we're leaving on the table. This is what is present in slide 2. This is present in slide 3. I'm going to give 1 more minute to just read all the data points, and then I'm going to read it slowly and construct it list. I also checked, and the 4th wicket has fallen, and India are more than 100 runs away. So Virat Kohli is still there. Hopefully he'll be there at the end of the session as well. Well, I'm going to read this. Applicants for the doctoral programs of Ambi Institute of Engineering and Bambi Institute of Engineering have to appear for a common entrance test. The test has 3 sections: physics, chemistry, and math. Among those appearing for CET, those at or above the 80th percentile in at least 2 sections and at or above the 90th percentile overall are selected for advanced entrance tests conducted by AEE. AET is used by AIE for final selection. So this is initial selection. You get 90 overall, and above 18 at least 2. And remember, above 18 at least 2, not in everything. For the 200 candidates who are at or above the 90th percentile overall, based on CET, the following are known about their performance in CET. So this 200, some subset of this is going to qualify for AET. Remember that. For AET, the constraint is you should get 90th overall and at least 80th in 2 out of the 3. In at least 2 out of the 3. If depends. So some subset of this 200, some fraction of this 200 is going to qualify to write the AET. No one is below the 80th percentile in all three sections. Straight away, by this time, you should have said, oh my God, this is one of those sets. One of which sets? One of those sets where we're going to draw something like this. 200 overall, 0 here. You should be on that track by the time you read this. If you're not on that track and you're going to write a series of constraints and equations, you've not sensed Venn diagram yet, then you're in trouble. Then you need to go revisit set theory and logical reasoning, do lots of questions where this language comes into play. Being given a physics, chemistry, and math, you're told at least 2. So you're going to have A intersection B, B intersection C. You're going to speak that language. Right? So remember that. So let's look at this. No one is below the 80th percentile in all three sections. That's good. 150 are at or above the 80th percentile in exactly 2 sections. Exactly 2 sections. That is this region, and this region. Those 3 add up to exactly 150. The number of candidates at or above the 80th percentile only in P is the same as the number of candidates at or above the 80th percentile only in C. Same as the number of candidates at or above the 80th percentile only in M. Fabulous. This simplifies life enormously. Seems to be a very easy question. PCM. This number, and this number are all same. The other 3 add up to 150. These 3 are equal. Outside is 0. This seems like a very easy question. Hang on, that's not what I said before. It's actually an incredibly tough question. It just looks like a lot of data points have been filled, but what is not filled is instructive. Let's look at the last nugget as well. The number of candidates below 80th percentile in P is to number of candidates below 80th percentile in C is to number of candidates below 80th percentile in M is 4:2:1. And below 80th percentile, that is P dash, not in P, outside of P. So outside of C, outside of M, ratio is 4:2:1. Till here, I was very happy. Saying some things add up to 150, some 3 things are equal, some one number is 0. I liked all of those. Here I have a ratio, not just 2 things, but 3 things. So, and this is P dash. P complement is to C complement is to M complement is 4:2:1. I already know it's one of those constraints with a lot of variables that are coming in. It's a pain. I know that I'm going to have to figure out a bunch of things starting there. Look at the next one. Still not done with the question. BIE uses a different process for selection. If any candidate is appearing in the AET by AIE, BIE considers their AET score for final selection, provided the candidate is at or above the 80th percentile in P. Incredibly complicated. BIE takes AET score if the student is appearing in AET, assuming that the student has scored more than 80th percentile in P. So I presume BIE is a physics-based institute. Basically saying if you're qualified for the AET, you're good enough, and you've got 80th percentile in P, you're good enough in physics, then you do not need to take another exam that I'm providing. I'll just take that score and you're through. Any other candidate at or above the 80th percentile in P in CET, but who's not eligible for the AET, is required to appear in a separate test to be conducted by BIE for being considered for final selection. Altogether, there are 400 candidates this year who are at or above the 80th percentile in P. Super, wonderful. There are 400 candidates who are at or above the 80th percentile in P. All of them are going to be eligible for BIE. Some of them are going to be selected based on the AET. So few of them who've got 80th percentile in P and at least 80 in at least 2 of the 3 and at least 90 overall would have automatically written the AET. So we'll take their score. The remaining who don't tick all these boxes but have got more than 80th percentile in P, we have to write this BIE exam. And so one set of criteria greater than 80 in P, yes, no. No, you're out. If it is yes, then the next set of criteria Eligible for AET also? Yes, then your AET score counts. No, then you write some BET score, a separate test conducted by BIE. That's how the algorithm is. But BIE is a physics-centric institute. That's what we can infer. So 88th percentile in physics is mandatory. If you've got that and also happen to satisfy a bunch of other conditions required for AET, then you are BET, BIE plus physics plus. So it's okay. So you have other things also going for you. Good. So we'll take your AET score. But if those other things are not satisfied, and therefore you're not writing your AET, but you've got more than 88th percentile in physics, we'll still take you on board after writing an alternate test. Wonderful. A bunch of questions here. Critical thing here, this seems to be a lot of information. So here, unlike the previous question, I think we'll have to end up solving quite a bit with the existing constraints and figure stuff out based on the existing constraints. And then we'll go to the questions. The questions could be useful, could be instructive. There could be some catches, caveats in the question, but I think there is something to do with the stem here. So, I'll draw the diagram. Greater than 90th percentile overall is 200. No one is below the 80th percentile in all three. That is 0. This is 0. Total is 200. X, Y, Z. These three add up to 150. Done all this. Wonderful. So bang in the middle, let us call this as K. That's also wonderful. So no one is below 80th percentile in all three. This we have incorporated. This we have incorporated. Let's build on this. These three are equal. We've already seen that. A. Wonderful. And so this plus this is 150. So 3A plus K is 50. So we don't have that many variables. This K is linked to this A. That's useful. So we got that far. That's super. So now comes the trickiest part. We've incorporated the first simple constraint. Outside is 0. All three are A. X plus Y plus Z is 150. That we have done. Now we come to the P complement part. It's a tricky part. Right? What is not in P below 80th percentile would be A plus X plus A. Thankfully, this is 0. A plus X plus A. Not in C is A plus Z plus A. Not in M is A plus Y plus A. Whereas below 80th percentile in P is 2A plus X. Below 80th percentile in C is 2A plus Z. Below 80th percentile in M is 2A plus Y. Now comes a tricky part, wonderful part. This ratio is 4 is to 2 is to 1. We multiply this by 4 and this by 2 and this by 1. All three should be equal. This is 4 times of this. This is 2 times of this. This is 2x of this. And so, fabulous. And so, now it looks like we can solve this and go somewhere with this. But remember, 4 is to 2 is to 1. Actually, 2 equations. 4 is to 2, 2 is to 1. If you write those 2 equations, the 4 is to 1 equation will be a derivative of this. The 2 independent ratios that are given here, not 3. X plus Y plus Z is 150. That is one equation. But we have an X, Y, Z, and A. K is not a new variable. K and A are linked. You get one, you get the other. We have X, Y, Z, and A. And we have 2 equations with this ratio and 1 equation with the idea that X plus Y plus Z is 150. So we can manipulate this for quite a while, but we're going to probably struggle to solve 3 equations in 4 variables, X, Y, Z, and A. And the equations are complicated enough with a lot of ratios. And this is where I really struggled when I solved this question for the first time. I wrote P dash is 2 times C dash, formed an equation. C dash is 2 times M dash, solved it, formed an equation. Tried to incorporate that into X plus Y plus Z equal to 150. Tried to get all kinds of ratios. I went mad, went berserk. And so the key takeaway from all my travails there is anytime you get a question with multiple ratios like this, 4 is to 2 is to 1, 3 is to 11 is to 14, 7 is to 19 is to 37. 3 ratios like this. Use them. Use them extensively. How do I use them? I'm going to call 2a plus x as 4m, 2a plus z as 2m, 2a plus y as. And so this is very useful. So now I can reframe x, z, and y in terms of m. I can say x is 4m minus 2a, z is 2m minus 2a, so, and y is m minus 2a. So I'm calling x, y, and z in terms of a single variable, making life simple for myself. We're given a big ratio, skip that ratio. Very often that ratio is a wonderful starting point for your variables. An important idea, if you're told a is to b is to c is 4 is to 7 is to 11, call them 4k, 7k, 11k, and then work out the other bits. Second point here, we know that a plus a plus a plus k is 150. 3a plus k is 150. All of these are positive. 3a plus k is 50, not 150, sorry, 50. And 3a plus k is 50. A plus a plus a plus k is 50, or a is less than or equal to 60. It could be even 0, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, all the way till 60. Only that many values are possible for this a. And remember this, because sometimes being street smart and framing the question differently is very useful. I'm going to work on that. And so we discussed this. 2a plus x is 4m, 2a plus z is 2m, 2a plus y is m. I know that this x plus y plus z is 150. Somewhere I want to use that. That's a bazooka. So I'm going to say, how do I use that? If I add these three equations, I'm going to carve out an x plus y plus z. Fabulous. So I'm going to add those three equations. So 2a plus x plus 2a plus z plus 2a plus y. 6a plus x plus y plus z, 7m. Wonderful. This is a fabulous equation because now I'm dealing only with two variables. X plus y plus z is 150. Or we know that 150 plus 6a is 7m. 150 plus 6a equals 7m. We are home and dry. Using just this, we can figure out everything else in this question. 150 plus 6a is 7m. Remember, a could be 0, 1, 2, 3, 4, 5, 6, all the way to 16. A is a whole number. A cannot be negative. A cannot be 17 or more. Okay. I'm going to do a bit of trial and error. So think about this. Let's say a is 0. 150 equals 7m, doesn't work. A is 1. 156 equals 7m. Is 156 a multiple of 7? 140 is a multiple of 7. 154 is a multiple of 7. 156 is not a multiple of 7. A equal to 2. 162, not a multiple of 7. Let's go step by step from here and try to locate a multiple of 7. Fabulous idea. Think about it. The numbers I have are 150, 156, 162, 168, 174, 180, 186, 192, 198, 204, 210, 216, 222, 228, and so on. They're not a multiple of 7. 154 is a multiple of 7. 161 is a multiple of 7. We have a winner. 168 is a multiple of 7. Fabulous. Or if I have 150 plus 6a equals 168, I'm through. 150 plus 6 into 3 is 7 into 24. That's a possibility. And then I keep on adding multiples of 6. I need to get a multiple of 7. This works. The next step that will work will only be 150 plus 6 into 10. I need to add a multiple of 7 here. So if 6 into 3 works, the next step should be 6 into 10. I'm adding 7 more 6's. That will account for 6 more 7's. 150 plus 60 equals 210. 150 plus 6 into 17 will be equal to 7 into 36, but this is not possible. Or I have two possible values. Or A could be 3 or A could be 10. If A were 3, then M would be 24. If A were 10, then M would be 30. Either I have 3 and 24 or 10 and 30. I'm going to plug in 3. I mean, this is 3, this is 3, this is 3. The remaining would be 41. Wonderful. I have x plus 2a is 4m, or x plus 2a, I'm going to write down somewhere here, x plus 6 is 4m, or 96, 24 into 4, or x is 90 here. Z plus 2a is 2m, or z is 2m minus 2a, which is 48 minus 6, 42. Y is m minus 2a, 24 minus 6, which is 18. So not P, less than 80th percentile in P is 96. Less than 80th percentile in C is 48. Less than 80th percentile in M, so leaving this out, is 24. 4 is to 2 is to 1. That ratio works perfectly. Right. All the numbers, these 4 numbers add up to 50. Everything put together adds up to 200. These 3 add up to 150. Got this completely done. The other possibility is that A could be 10. So this is 10, this is 10, this is 10, 30 gone, this should be 20. That works fine. After that, we know that x plus 2a is 4m, m is 30, x plus 20 is 120, or x is 100. That goes here. We have z plus 2a equals 2m, z plus 20 equals 60, z is 40. Y plus 2a equals m, y equals 30 minus 20, which is 10. These 3 add up to 50. The overall numbers are P dash is 120, C dash is 60, M dash is 30. 120 is to 60 is to 30 is 4 is 2 is to 1. That works. All numbers put together add up to 200. That works. The P only, C only, M only are 10, 10, 10. That works. All 3 are equal. So fabulous. So we have 2 possibilities now, 3 or 10 for P only, C only, and M only. And then for each of those combinations, you have multiple sets of answers. So remember, this started off as a fabulous logical reasoning puzzle, became a Venn diagram question, then went on to become a ratios question, finally became a number theory question. The whole crux of solving this is 150 plus 6a equals 7m. So be street smart. Anytime, what the takeaways from here, anytime you're given a ratio-based thing, start with your variables with a ratio-based thing. Anytime you have lots of variables and maybe more than one solution, don't go down the algebraic route, go down the street smart route. You know that A cannot take any value. A can only be from 0 to 16, and M can also correspondingly be only set of values based on what A can be. So try to solve and try different possibilities rather than algebraically framing equations and solving that. The CAT has cranked up the level of difficulty. Multiple solutions are possible. They want us to think about set theory, Venn diagram, ratios, and number systems at the same time. We're effectively solving for 150 plus 6a equal to 7m. So be street smart about this. Now let's go to the questions. What best can be concluded about the number of candidates sitting for the separate test for BIE who were at or above the 90th percentile overall in CET? At or above 90th percentile CET. In this category, the only guys who will write BIE are the ones who got above 80th percentile in P, but not in one more beyond P. They've got more than 80th percentile in two of the three, then they'll write AET. They're not writing AET. They're writing the separate exam for PIE. They should have got above 80th percentile in P, but not in C or M. Effectively, this question is saying, give me the number sitting inside P only in your Venn diagrams. P only could be 3, P only could be 10. Very simple question, but incredibly trickily worded. You're saying, among all your guys with greater than 98th percentile, which ones have to write the BET exam, the other test conducted by BIE? For writing BIE, you should have got more than 80th percentile in P. So I'm looking at only P, but you should not have written AET. AET you will end up writing if you've got more than 90th percentile overall and more than 80 in at least two of the three. So if you've got P and C and P and M or P, C and M, you've written AET anyway. So you're looking for P only in this bunch. That is 3 or 10. Wonderful question because the way it is worded. The number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in all three sections in CET is a multiple of 5. What are the number of candidates who are at or above the 90th percentile overall and at or above the 80th percentile in both P and M in CET? Basically, he's saying the number in between this number is a multiple of 5. All three is a multiple of 5. All three could be either 41 or 20. It is not 41, it's only 20. So effectively, all this guff is to select this Venn diagram and not the other one. Now let's look at the question. What are the number of candidates who are at or above the 90th percentile overall, effectively within this Venn diagram, and at or above the 80th percentile in P and M? P and M. P and M would be this 40 and this 20. P, M and C. That's all right. P and M, I'll have to count both. 40 plus 20, 60. It's a theta question. Don't end up writing 40. They're not saying only P and M. They're saying P and M. So it could be PM, PM and C. Guys who have got above 80th percentile in all three have definitely got above 80th percentile in P and M. That is included. So 40 plus 20, 60. If the number of candidates who are at or above the 90th percentile overall and also at or above the 80th percentile in all three sections in CET is actually a multiple of 5. Once again, it's taken as that Venn diagram where the middle number is 20. Then how many candidates were shortlisted for the AET by AIE? AET for AIE, not for BIE, for AIE. AIE condition is more than 90th percentile overall and at least two of the three. So in this diagram, we'll count this, 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 and this. So 150 plus 20, 170 get shortlisted to write the AET. These 10, 10, 10 cannot write the AET because they have not satisfied the second criteria, which you should have got at least more than 80th percentile in at least two of the three, P, C, and M. Go to the last question. The number of candidates who are at or above the 90th percentile overall and also are at or above the 80th percentile in P in CET is more than 100. How many candidates had to sit separate test for BE? Above 90th percentile overall and above the 80th percentile in P is more than 100. So this we are selecting from two Venn diagrams. So we're looking at either this one or this one. So if it were this diagram, then you're dealing with 40 plus 20 plus 10 plus 10. It adds up to only 80. In this case, it will be 42 plus 41 plus 18 plus 3. 21, 62, 104. So effectively, we are being told if the situation were like this. The initial conditions for all of these questions are basically saying, are you selecting the 3-wala Venn diagram or the 10-wala Venn diagram? That's it. There are two possibilities. Each of those questions basically says which of the two is relevant for that question. So you take the stem and carve out both Venn diagram. And each question says, okay, this time we look at the 3-wala diagram, this time we look at the 10-wala diagram. That's all there is to this. Okay? Now let's look at the question. It's more than 100. So effectively, we are dealing with this. How many candidates had to sit for the separate test for BIE? So let's do this. Among the guys who had got this, who had taken AET, would be this, this, and this. This three cannot have taken the AET. So 18 plus 41 plus 42 are eligible for BIE, and within this sum, all of them would have taken the AET. So 2 plus 1, 3, 11, 1, 1, 2, 6, 10. 101 guys have taken the AET. There are 400 guys who are eligible for BIE based on the fact that they've got more than 80th percentile in P. Of these, some could have just taken and tried for BIE through the AET, which is 101. The remaining who have qualified based on their physics but have not got all these other things in order to write the AET, have to write the separate test for BIE. Or out of the 400 who have qualified, 101 write and attempt to get in through the AET. The remaining 299 have to write the separate test. It's an absolutely awesome set of questions. I made like multiple sets of mistakes trying to crack this. And so I had a long, difficult task trying to solve this. I spent a long time, made a bunch of mistakes. I've learned a lot in trying to just solve this question. I'm going to capture all the things that I learned. Don't underestimate this exam. We're effectively saying we can take a question, make it sound innocuous like to enter the exams, and then add a layer of Venn diagram to it, add a layer of ratios on top of that, 4:2:1, and then add a layer of number systems on top of that, end up with two solutions, and then carve out questions after that. So don't underestimate this exam. I think I did that, and then I struggled. Second thing, if you're given a ratio 4:2:1, then that very frequently that ratio part becomes the best part to start. Something is 4:2:1. Start off by saying, I'm going to assume the numbers as 4m, 2m, m, and then reshape your rest of the equations from there. Don't deal with an x by y is 4:2, y by z is 2:1, x by z is 4:1. Don't do that when you're dealing with three variables. Some three things are in the ratio of 4:2:1, 4m, 2m, m. And then shape the remaining from this. It's a very useful idea. And if you're given a constraint and multiple solutions are possible, then your street smart number systems based idea is probably going to work better than saying I'm going to solve this algebraically and frame different equations. So, wonderful set of questions. I thought that we would run out of time just doing these two. So I'm going to stop with this. I'm going to log out of our screen sharing thing and then come back to the live session and wind up with that. And so wonderful session, damn neat set of questions. As far as the question, I'm getting a bunch of questions. Would you recommend attempting a set of this level of difficulty in the exam? First one, definitely yes. Second one, probably no. And so the first one is very, very doable. You get a couple of simple things. You can get all four right. Second one, properly tough. Bunch of different ideas. Fabulous to discuss and go through and see and crack and learn something. But in the exam setting with pressure playing a role, probably not. And so good set to solve. I hope you all enjoyed yourself. With some quick to ask whether we will have more sessions like this. Definitely yes. We want to solve. We've solved every DILR set in CAT 2017 slot 2. We're going to solve every DILR set in CAT 2017 slot 1 as well. We've done 2, we're going to do 6 more. So probably we'll have 3 1-hour sessions like this. All the best for your CAT. I hope you have good fun preparing for it. You enjoy it. Make sure you have fun solving these puzzles and don't do them in a state of stress or pressure. Best wishes. I'm going to sign off now.